In 1979, Science of Cambridge were advertising a VDU card for the MK14. It had a PAL TV interface and could output 32 lines of 16 text characters or a 64 by 64 pixel graphics mode. In December of that year, Practical Electronics published the source code for what is probably the best known and earliest graphics application for the MK14. Called Falling Man, it required 256 bytes of RAM for the program and 256 bytes for the display. Whilst Falling Man gives a hint of the possibilities, the biggest drawback for the MK14 was a lack of RAM. With only 512 bytes, half of which was needed for a minimal 64 by 32 display, there wasn't much left for programming. Nowadays, the standard MK14 configuration adds another 1.5K of RAM via an expansion module, which greatly increases its usability. This video is going to demonstrate MK14 pixel and line drawing routines, developed specifically for use with the expanded MK14 and VDU card. The first demo program starts with random pixel plotting, followed by random line drawing. Seven lines are being drawn and undrawn in a snake-like chain within the 64 by 64 pixel boundary. The line drawing routine is an enhancement of Bressenham's algorithm. A 16-bit pseudo-random number generator provides coordinates used here to draw random triangles and random rectangles. Drawing concentric squares gives a good idea of the speed achieved with the standard VDU card. One feature of the VDU card is that it stops the CPU from processing for about 50% of the time, pretty much like the ZX81 slow mode does. Despite this, it is still possible to generate some fairly fast-moving displays. This second demo uses the plot and draw routines to build some blocks that could be used in games. In this small section of a Pac-Man game, the X-Y position of the sprites is changed dynamically to animate them. Text characters and sprites are each defined as an 8x8 matrix and plotted to the screen. The line drawing routine is shown to great effect when drawing random views in a 3D maze. Or what about a 3D maze version of Pac-Man? It's all possible but would require a lot more program RAM. Another feature of the MK14 VDU module is the ability to split the screen and have one half in character mode and the other in graphics mode. Shown is the 3D maze, along with a 2D overhead view of the maze. The upper section of the screen can be used for messages and instructions. In the 2D view, your position is identified by a flashing pixel each time you move. Another example of split-screen graphics, and the use of sprites, is the Jackpot Fruit Machine. The SC-MP processor clocked at 4 MHz achieves a massive 0.5 MIPS. Bearing in mind that the VDU card steals half the time for itself, this results in 0.25 MIPS. That forces you to think about how best to present the graphics and how not to overload the processor. But what if we had even more memory, like this MK14 with 32K bytes NVRAM? And what if we were able to increase the VDU resolution? In a future video, we'll take a look at the realities of doing this. Thank you for watching.